Hello data fan! Streamlit has just updated to version 1.53, which comes with Starlette support. And this is a game changer, because Streamlit has always locked out its Tornado server from us, so we never could customize it. But now we have the key to it. Here's my master demo. I've got this main page and multiple custom demos. Like here, I can use Streamlit to interact with APIs defined on the Streamlit backend. For example, I can fetch raw JSON from API raw data, like this. I've got some JSON here, or an HTML fragment. Let it fetch. Here, you've got your HTML fragment from Streamlit's backend server. To enable it, let's go to our code editor, and inside our .streamlit/config.toml file, we enable the flag at server use Starlette to true. And then we split our Streamlit project into two files. We still got our streamlit_app.py file, which contains our Streamlit frontend with the home page and a multi-page of apps that come from this apps folder here. But now we also got our app.py file, which contains the logic of the backend from Streamlit. Inside, we use our new Streamlit Starlette App object, which we initialize, let me scroll, to a new app object that points to our streamlit_app.py frontend UI. And then to start it, we run Streamlit, run Streamlit run app.py file instead of the frontend streamlit_app, or we mount it directly on UVcorn with UVcorn, the file path, and then the name of the variable, and then we can use the reload flag. And today is the day we break out that backend server out from Streamlit. We define those API endpoints inside asynchronous functions, like this custom Starlette data or HTML response demo. And those return Starlette-specific classes, like the JSON response with the type raw Starlette and some data we get from an API, or this HTML response with the HTML fragment. Then we mount those functions into our backend system by using, let me scroll, this routes list. So don't pay attention to the routes at the end here. Let's focus on the first four. We route our API raw data to custom Starlette data, which returns JSON. We route API HTML demo to our HTML fragment, and etc. Hi data fan, editor fan here. I forgot to mention that this routes list, you need to inject it as argument of the ST application, otherwise it's not going to be mounted. There you go, see you soon. And now we got those API endpoints, and if you don't believe me, I can type raw data here, and I get my JSON raw 10, 50, 30. And this is all thanks to Starlette, which is now free to provide all of its powers to the Streamlit app. Being able to interact with custom endpoints in Streamlit is awesome. Now you can send payments to Stripe and wait for a callback by using a custom endpoint, or you can host your HTML page from this custom endpoint. But you may ask, what is this Starlette and how does it link back to our Streamlit application? Let me explain. Starlette is a lightweight ASGI toolkit to build high-performance asyncio web services. It is famous for bringing async capabilities, middleware, routing, cookie support, background tasks to FastAPI because it's a Starlette app subclass. And now we got the same with the Streamlit app because ST app, that's how I call it, now follows the Starlette application standard. In that way, ST app inherits a lot of the Starlette features, almost like FastAPI. Like it's like they're brothers at this point. And one of the most practical use cases Starlette brings to Streamlit is our vibe-coded landing page. I'm on a second demo here, serving static assets, and when I click on this button, it's going to redirect me to the /landing path. And there you go, my magnificent vibe-coded landing page, which is hosted on the same server as your Streamlit app. Now you can go back to the Streamlit dashboard, or you can view the API docs, but that's a spoiler for later. To serve this landing page, I use Starlette static files that points to the directory of landing, which is here, and this landing contains my index.html and my styles.css with only one glass CSS class. I map this directory to the subpath landing, and by putting HTML to true, I ensure that this index.html is the one being used by default when I land on /landing. Finally, by using the mount class instead of the route class, I make sure that any of the subpaths after landing is also taken into account. A little note here because I tested it, but don't try to host it on /static. I think it's busted because it's conflicting with Streamlit's own static assets. Which means you can host your marketing website, your documentation, your wiki, your whatever you build with HTML, CSS, JavaScript. And now that you can manage which files are exposed to the web, you can also manage how the web sees your app through its metadata. Here I define a robots.txt, sitemap, or manifest.json. When I click on those, here's my robot with user agent. Everyone can scrape my website, and here's the address to my sitemap if you want to. And on the sitemap, there's a list of all the paths that you can traverse, like the base localhost with 1.0 and my landing page with a priority of 0.8. Finally, I got this manifest.json. I'm not really sure how it's being used. I think it's to add progressive web app features to improve search visibility and the mobile experience for users. I think they're able to install the icon for the app on their mobile home screen. I'm not really sure. But yeah, this improves SEO, and it's easy to do again with those asynchronous functions to return a text response or your sitemap with a basic response of media type application XML. At this point, a Streamlit app is basically like a FastAPI app. Like, they can probably host each other like brothers, right? Here's a new demo where I try to mount FastAPI inside of Streamlit's Starlette backend server. I've got a health check, which I can ping to get back the health status from inside the server, or I can predict if I put some machine learning model inside FastAPI, I can immediately hit the API for some predictions, like 42, and I can even, this is my favorite feature from FastAPI, I can open its auto-generated documentation, and I can ping the health from there, try it out, execute, and it's going to ping localhost /health/API/health, and I'm going to get my healthy situation. And then just to make sure this really works, I can also ping it, and you've got your JSON here. If I show you the code here, I create a new API FastAPI object with the health endpoint here and the predict endpoint here. And in the same way as the Starlette files, I mount it inside my /API endpoint so that all of the sub endpoints like predict or health check are taken into account. And apparently you can do the inverse. You can also mount Streamlit into FastAPI or Flask or even Django. At this point, like a Streamlit app really is like a FastAPI or a Starlette app object. There is a Starlette feature I really wanted to try to display real-time metrics inside our Streamlit UI. Okay, my demo is loading, and there you go. You've got a live data stream inside Streamlit that updates every half a second. I can make it slower from the slider, or I can make it way faster. And there you go, it's live static display inside Streamlit without having to rely on reruns. But how does it work? Starlette can expose WebSocket routes by using this asynchronous WebSocket endpoint that takes as argument a WebSocket input. And then it can wait for a connection with this accept, and from the interval that I get from the query parameters from my Streamlit UI, I can open a loop, an infinite loop, where I take a random number from 1 to 100 and send this as JSON inside the WebSocket. So like every half a second, I am sending from Starlette to the Streamlit app through a WebSocket some random number. But then I don't really want to use Streamlit reruns to connect to this WebSocket route. So instead, what I can do is connect by using JavaScript inside the new component v2 for Streamlit. Let me show you. I just need to open the demo. It is the demo WebSocket, and here I am going to build an HTML argument that will contain some connection followed by this waiting for data WebSocket output. And then I got some JavaScript where I connect. Wait, where do I connect? Here, where I connect to my WebSocket, and then I point back to my div of status and output that I define inside the HTML. Finally, every time I get a message from the WebSocket, I parse the JSON to get the data out of the JSON, and I update my HTML output elements with the new WebSocket data here. And then finally, when I close the demo, I remove and disconnect the WebSocket tunnel. And this way, I get my real-time update inside a scoped HTML component that is independent from Streamlit reruns. That way, I got full stack separation of concern. Streamlit UI to visualize and control, Starlette for any backend logic, machine learning, etc. And another big component I loaded initially in Streamlit apps for chat applications is MCP servers. I didn't have time to build a chat application that would call a certain tool from the MCP server. I did build a MCP server that I'm hosting inside Starlette and that I can call immediately. Enter your name to call the greet tool from MCP, and I will call myself. And there you go, response from MCP, hello Fanil. This comes from the MCP server inside Streamlit. The official MCP server, FastAPI MCP, FastMCP, they all can translate to FastAPI apps. If I define a FastMCP server here with a tool called greet that takes a name to return hello Fanil, this response came from the MCP server inside Streamlit. I can transform this MCP app into a FastAPI app with this HTTP app method. Let me confirm. Create a Starlette app using the specified HTTP port. As always, I can mount this MCP server inside a new subpath like analytics. Then in my demo, I use FastMCP client to connect to this API endpoint. If you really want to see it, here's my client that connects to Analytics MCP. You can find the code source inside the description below. But wait, there's a little issue here because we need to start this MCP app server before Starlette's lifespan. You need to keep that in mind because I need to do it later. Starlette brings more than just mounting all sorts of apps. It has built-in security at the server level to prevent attacks and control access to the Streamlit UI. I've got this small demo here. It tells me to open my browser DevTools, which I'm going to do. Here's my browser. Don't pay attention to this. We are going to check the network. Reload the page. And here's my HTML document, which is this security headers part. And if I open the headers to it, you will see my X-frame options as same origin, content type as no sniff, and strict transport security as maxed age is here. And those security headers are set up from Starlette. Starlette intercepts any inbound request or outgoing response by using middleware to catch every of those before or after it reaches your code. For example, this security headers middleware here intercepts every response to inject security headers like this X-frame options to same origin or X content type options to no sniff. Now, don't ask me exactly what those do. I think they instruct the browser to enforce some security thing. Those headers secure the connection ingoing or outgoing the Streamlit server. But what about protecting user sessions and logging state by giving them a little badge to wear to enter the door? Streamlit can access cookies set by Starlette middleware via the stContextCookies method, and apparently I've got a cookie inside session ID with the value of ABC123demo. And to make sure that's not a lie, we can head to our cookies inside the storage tab of our DevTools, and indeed inside localhost we have our session ID cookie. It also has some attributes like HTTP only or secure false, which I think makes so that I cannot steal them from the JavaScript cookie. There you go. There are a lot of cookies, but there's no session ID cookie from Streamlit. And I can show all of the cookies. This is to show that I can access all of the cookies from the Streamlit code. Going back to Starlette, I can set a cookie at the response level. So beforehand in the asynchronous functions with the response, if I go back at the top, each of those responses here can take a set cookie, so that when I hit the custom Starlette data page, like this page, I get the specific cookie from this page. And I can also use a middleware like this one, so that every response reinitializes the cookie, like this session ID ABC123. There are two ways of setting cookies. For internal tools, you'd want to control who can reach the page with a guest list. This is a fake demo because I didn't plan on how to spoof an IP, but if I use a visitor IP of my neighbor, because my neighbor wants to access my network, well, the Streamlit app is going to be blocked. Starlette is going to send back a forbidden message here. But if I use localhost to connect, test access policy, I will see a success. Okay, maybe I should deploy this somewhere to actually test it. This whitelisting feature has a dedicated native middleware to restrict access to internal tools by client IP. I got my allowed IPs here, and depending on if it's in the list or not, you can call it and say stop or please enter. Then in the same way as my routes, I have my list of middleware that each request and response is going to traverse with the cookie middleware, the IP whitelist middleware, and the security headers middleware. And I'm using this list of middleware inside my middleware argument. Now my Streamlit on Starlette app is protected by Starlette middleware. I only showcased 3 native Starlette middleware, but because FastAPI and Starlette got successful, there is now a large ecosystem of middleware to pick from rate limiting to CORS management to sending stats to Prometheus. There's all you need with Starlette to secure your Streamlit app from the dangerous outside world. Now that Streamlit is protected, maybe it's time to focus on Starlette's life. Especially if Starlette has to load heavy machine learning models or FastMCP servers with 1000 tools from agent skills and etc. before streaming this app. You can register a function to run before Starlette starts up or after Starlette is destroyed. I can run some login before the startup and some login outside the startup after it's destroyed. Let me show you the code. Here's my fake database connection to connect to some MySQL or PostgreSQL remotely, and a machine learning model because I want to predict something. And I've got this new lifespan method here, in which I connect to my shared database connection and I pre-warm my machine learning model. And do you remember I told you we needed to start this MCP Starlette app before our Streamlit Starlette app? Well, you can synchronize the lifespan by using the dedicated lifespan method. So here this MCP app lifespan will be linked to our Streamlit on Starlette app. And everything that comes after this yield is some cleanup methods after the Starlette app destruction. For example, disconnect from the database. And now your Streamlit app should be fully responsive from first visit because your Starlette backend has done all of the warming up, starting the database connection and machine learning model before displaying the actual Streamlit UI. Finally, I use this lifespan hook as my lifespan argument so that my startup and shutdown hooks are correctly defined. But what about if we need to handle heavy tasks during the Starlette server lifespan? Here is a very heavy background task. I need to send an email to user@example.com with a PDF that takes the processing from my previous LLM. Let's trigger the background task. And okay, this is Starlette responding, but this is immediate. I immediately get a response of this sending email is being queued, and now you can do something else. But this email in the code, it actually takes 5 seconds or 2 seconds, I don't remember, but it takes a lot of time. And I'm not going to wait for 5 seconds for a JSON response from the API. Here's my very heavy send email task. As you can see, it's very time consuming. I have to wait for 2 days, seconds, but days, before it does anything. And I'll use this as a background task in this background task class for my API endpoint for background email. And every time I hit this API, I immediately get a response and I queue the execution of this function in the background. This provides a much smoother user experience without blocking your Streamlit app, telling you that it's still running, you cannot do anything else while it is running. And when things go wrong in the life of Starlette, don't ask Ralph, handle errors like a pro. Here's a demo to show you what happens when there's a problem inside the Starlette app. For example, this API trigger error has a big Python problem like dividing by 0. So when I go to this API, instead of getting a divided by 0, I get this HTML500 status page. Something went wrong, sorry, please try again later. And I can go back to my Streamlit app. Oops, let's go back to our page here. There's also this /landing/missing HTML. This doesn't exist. If you remember, in the landing page, I only got index and styles CSS. So when this doesn't exist, I get a 404. Oops, the page doesn't exist. Last but not least, I got this /random page. But because this is using Streamlit multi-page, what happens here when I click on it is I go back to default Streamlit navigation with a Streamlit page not found. So we've got those 3 types of errors. We designed our stylish HTML errors for 404 and 500. Here in those string, there's a big HTML. I should extract those in an HTML page and just load them inside the Python code, but whatever. Here's my HTML 500 with a lot of CSS so that it looks cool. Then I put those in not found and server errors. Here, HTML response with this status code 404 and HTML, and this one here. Finally, I put a dictionary of status code and not found server errors that I use at the app level part in the exception handlers argument. You got so many new features just by adding the Starlette powers inside Streamlit. So you can start treating Streamlit as the micro full stack library for data apps. And in this release, there's also more enterprise features like authentication or OIDC tokens are now accessible, or you've got ST logout, you've got session scoped caching of data and resources, still a lot more that I did not talk about. Like, it's amazing how much we get at the start of 2026. I'll see you around, data fan. Bye!